All right, we're continuing with rational expressions, and we are now going to work on operations adding and subtracting. We're going to begin by reviewing simply adding fractions algebraically. If I wanted to add these three fractions together, I would need a common denominator. My common denominator would be 63. So the first thing I would need to do is write equivalent fractions. That means if I need to multiply here by something to get 63, I need to do the same to the top. So 7 goes into 63 9 times, so this would be 27. If this is 63, 9 goes into 63 7 times, so this is 35, minus 6 over 63. Now that I have written equivalent fractions all with the same like denominator, I may add across the numerators. So I'm going to take 27 plus 35 and get 62. And then I'm going to take 6 away from 62 and get 56 over 63. In the end, I want my fraction to be in lowest terms. So what goes into both of these numbers is 7. So I'll end up with 8/9 as my fraction in lowest terms. We're going to do the same thing with rational expressions. It's just that we will have variables now included. So for example, this is what we're going to work on making have like denominators so that we can add and subtract. Here are the steps. You want to factor the denominators to find the least common denominator. You're going to write equivalent fractions whose denominator has the LCD from step 1. After step 2, your fraction should have like denominators. Step 3 is now to add or subtract numerators and write the sum or difference over the LCD. Now, in the end, you want to simplify the rational expression to lowest terms. So the first that we're going to consider is simply one that already shares a like denominator, but there's an error that has occurred. When we have the same like denominator and we are using a subtraction sign, the error that has occurred is this subtraction sign needs to be distributed through the entire numerator. So this -1 is my error. If the work is done correctly, it would be x minus 4x plus 1 over x plus 2. Which is negative 3x plus 1 over x plus 2. We're now going to work on examples that require us to have the same common denominator. If I look at the first example, I see that this second denominator is 4 times x. So this first one also needs to be 4 times x. So my LCD is 4x. So if this is missing a 4, then I need to also multiply the 5 by 4. So I get 20 over 4x plus 9 over 4x. Which now, since I have the same common denominator, I can add the numerators and get 29 over 4x. 4 doesn't go into 29, so my fraction is in simplest terms. When we get to a problem like 2, you want to think about x plus 3 being its own factor. So our LCD has to be x times x plus 3. Then the easiest way to make common denominators to ask yourself, what is this denominator missing? It is missing x. So if I need this to be x times x plus 3, what I have put in the denominator is x. To write an equivalent fraction, I must also put x in the numerator. minus 9 over, if this has x, it needs x plus 3. So here I'm going to also have to include x plus 3. Now we have like denominators with the same LCD. I can now write one fraction with my denominator being x times x plus 3. The numerator, I'll start with 5x, and now I'm going to distribute my negative 9, so I get minus 9x minus 27. I'm going to combine like terms and get negative 4x minus 27 over x times x plus 3. To see if this fraction in the end is simplified, we would check to see if the numerator factors. Nothing factors here to help us cancel, so we have an answer in lowest terms. Problem 3. The easiest way to begin problem 3 is to look at this third denominator and factor it out. So we're going to say x times x minus 2. That helps me see that my LCD is x times x minus 2. Again, whatever is already present in the denominator is not what is missing. What's missing here is x. So I'm going to write 3x over x times x minus 2. Plus, this has x, it's missing x minus 2. So whatever I have to do to the bottom, I must also do to the top. The third fraction has my entire LCD already, so no part of that fraction is changing. Now I can see that I have created the same common denominator, so I can write one fraction with my denominator being x times x minus 2. The top I'm going to distribute 3x plus 5x minus 10 minus 6. I'm then going to combine like terms. So I get 8x minus 16 over x times x minus 2. And again, to make sure that my last line is in simplest form, I check to see if the numerator can be factored. There's a common factor of 8 that I will take out. And then we can see that after we factor, we can cancel like factors. So I can cancel out x minus 2. My final answer is x in the bottom, 8 in the top. So 8 over x. Problem 4 is sometimes the trickiest one. X plus 4 has to be thought of as its own factor, as does x minus 7. So my LCD has to be one of each of these. So I need an x plus 4 and I need an x minus 7. The first denominator needs x minus 7. If I put it in the bottom, I must put it in the top. So this is 2x times x minus 7 over x plus 4 times x minus 7. Plus, the second one is missing x plus 4. If I put it in the bottom, I must put it in the top. So 3x times x plus 4 over x plus 4 times x minus 7. Now I see that my denominators match, so I can draw one fraction bar and say that my denominator is x plus 4 times x minus 7. To continue with the numerator, I will distribute 2x, and I will distribute 3x. 2x squared minus 14x plus 3x squared plus 12x. I am able to combine like terms. So I get 5x squared minus 2x over x plus 4 times x minus 7. Now we've been saying that our final answer needs to be simplified, and we say to check that by seeing if our numerator factors to help us cancel anything in the denominator. This numerator shares a greatest common factor of x, and if we took out x, we could factor it. but what's inside the parentheses would not match anything in the bottom to cancel. So this is in simplified form.